Alhamdulillah, summa salatu wa salam ala Rasulullah, Muhammad bin Abdullah, wa ala alihi wa sahabihi wa man wala abad. Good morning, my viewers. Good evening, my viewers, and also good afternoon, irrespective of how the location or weather is. So I'm greeting you. Good morning, good afternoon, and good evening. On our today platform, our SOPS academic online class, we're still going to be continuing from where we stopped under physics, which is electric field intensity, and electric potential. And I'm going to be joining another one to it, which is work done in terms of electric field and in terms of electric field intensity. How do we relate them together? So these are these. Firstly, there will be a little proving derivation of formulas, which JAMB might actually ask you, and which this formula that I'm about to be proving, which it is applicable for each question you meet in the JAMB program. So each question implies each formula to use. So that is why we need to, before we look into some review question regarding the JAMB past question, what are the likely questions they can ask under this topic. So let's quickly see all the formulas regarding this subtopic. After we see the formulas, then we'll be applying all these formulas towards what we are actually solving. So please stay tuned. Don't go anywhere and stay connected with me. And please don't forget to subscribe, share to the needies. JAMB remain like 18 days now, if I'm not that, or 17 days, or irrespective of the days. Please and please prepare where I wish you best of luck. Barakallahu fikum. Now, we stopped at the derivation of electric field intensity. Electric what? Electric field intensity, where I explained, please check the second video, episode 2 of this physics class, where I explained that it can be defined, or it could be referred to as the strength that an electric field undergo. It is the strength possessed by an electric field. Is what we know as what? Electric field what? Intensity. Or it is the ratio, I'm doing the recap, it is the ratio of force per unit charge. Is the ratio of force to its charge. Newton per coulomb. Force is there. I've put in all that in note in episode 2 of this class. What I'm going to be doing now, I'm going to be proving some formulas. I've proved one. It is denoted, the symbol for electric field intensity, it is E. I've proved formula 1. I've explained what formula 1 is, which is, I said, F equals to F all upon Q. I've proved that this is first formula for calculating the electric field intensity, where you are only given the force and the electric charge. We call this Q electric charge, while we call F, we call it force. So this is the formula to use. And in some cases, whereas there's no force there, there's no force there, but you're having K there, or you're having E naught there, or you're having radius there, which is what we call R, distance. In this topic, we call R, we call it distance. You're having all this, the formula changes. How together? So, but you can't use this since you're having K, E naught, and how to have proof that of K. Where we are actually going to, it is this E naught, to avoid repetition, where we discussed that we have it to be F equals to Q 4 pi E naught, or let me do like this, where we actually said F equals to K Q1. Let me do it like this for more. Let me just repeat this. I said F stand for what? S stand for Coulomb's law of electricity, where we said Q1, Q2, K equals to Q1, Q2, all upon what? All upon product of their distance that tear them apart. And I told you that substitute in the value of F. So I'm still doing the recap of what we done so earlier. Substitute it inside here. where we said E now will be wherever I'm seeing F, what will I be putting? That's where we actually explain this. I'll be putting what? I'll be putting, this is F, I'll be putting KQ1, Q2, all upon what? R square. This divide, this is all the value for what? F. Divide by, so I'm substituting the value of F here from Coulomb's law of electricity. I've explained that in the second video of this class. Please don't forget to go and check the second video for you to understand well on this. So this Q, the big divide is this one. This Q is this one. Now, this one is also the same thing as this. So let's try and do a mathematical expression here where we said E equals to K Q1 Q2 all upon what? R squared. This divide, put it here. This Q, make it here. And find a means to change this divide into what? Into multiplication by putting 1 here. 1 will go up, Q will come down. It will now be E equals to K Q1 Q2 all upon what? R squared multiplied by 1 all upon Q. This Q, irrespective of anyone, just cancel anyone. Q settle 1 Q here. Remain how many Q here? We are left with what? Only 1 Q. Where we discussed that. So therefore, I will be having what? I will be having E equals to what? E stands for electric field intensity. K Q1 or Q, anyhow you want to put it, all upon what? R squared. This is another formula for calculating what? Electric field what? Intensity. Now, in case you are having a JAMB, you are having a question in the JAMB program, and it implies K, Q, and distance. This is the formula to use. You deviate from this formula. So this is the second formula that I told you about. What of if you are having E naught, where I call E naught permittivity, E naught. The constant for E naught is 8.85. Please cram that. Times 10 raised to the power minus 12. Minus 12 farad per meter. Farad per what? Per meter. Hope I'm called F per M. So this is the constant. Please do well to cram the constant offhand. We call it permittivity free space of this particular subtopic. And I told you that the K, the constant K from the previous video, which is on episode 2, I told you that 9 times 10 raised to the power 9 Newton. This is what? Coulomb's constant. Coulomb's what? Constant, which is K. This is permittivity of a free space. Are we? So these are the constants. And please do well to cram this very well. So we are going to need it. That is that. Now, note, this is the second formula for calculating electric field intensity. What of this third formula that has to do with the inducement, the introduction of E naught? Now, follow me. Note that for we, if you are having a question in JAMB and E naught is there, Q are there, R are there, you don't use this one. What do you use? And you are not having K there. This third formula to use is that K equals to 1 over 4 pi E naught. Wherever I'm seeing K, what will I be putting? I'll be putting 1 over 4 pi E naught there. So let's substitute the value for K, the parameters for K inside this formula. So E naught now will now be, what is that? 1, wherever I'm seeing K, I'll be putting in what now? I'll be putting in the value for K. Are we together? So I can actually, even you can space it like this. I can actually say K times what? Q all upon what? All upon R squared. I've split it. When I times K times Q, it will still go back to this. R squared, which is the distance, over 1 times this, it will still go back to this. But why am I splitting it? It's for me to just input in my what parameters. What do I want to input? All this value, which will now be E now, will be what? What is our K? K is this. It will now be 1 over what? 4 pi E naught, which is the value for K, times Q over 1 all upon what? R squared. Hope I'm communicating. Now, this is what I'm having, isn't it? So, wherever I'm seeing K, what will I be substituting? I'll be substituting in these parameters. Hope I'm communicating. Which will now actually be what now? This now will be what now? It will be Q times 1. Q times 1 will give us what? Q. It now be Q all upon 4 pi E naught R square. So I've proven this one inside the what? Inside the something. Are we together? That means what we're actually saying, that all this K now, all this K, we are putting it that it should be what? It should be 1 over 4 pi E naught. Hope I'm communicating. So 1 times Q, that's what gives us Q. This times all this, that's what gives us this. Hope I'm communicating. That's what I actually do here. 1 times this, we get this. Then this times this, that's what. So this is the third formula for calculating what? Electric field intensity, where you have the electric charge. 4 is the constant. Pi, it is 3.142. This is the permittivity of the free space. Why this is the distance. So these are the formula that we use in calculating what? Electric field intensity. The fourth formula for calculating electric field intensity is this formula, which is the last formula on electric field intensity. It is E equals to V all upon D. V stands for what? Potential difference. Where V now, it will be potential difference, or we call it electric potential. That I'm coming to that. Or you call it EMF, electromotive force, or you call it voltage. These are the names that you can actually call V, and the SI unit is volts. Why this D? It is distance. In some textbook, you can see it as V over R. I told you that they can use it vice versa. D can also be the same thing as R. R can also be the same thing as D. Irrespective of this, the letter used, all are distance. Use R, it is distance. D, it is distance. So this and this is still the same formula. So in order to find the SI unit for this one, it will be what now? V stands for what? Volts. Voltage. While R stands for what? Meter. That is the standard unit. It will now be volt per what? Volt per meter. Or you can write it like this. So when you are given 20 volt per meter, know that it is electric field intensity that you are given. Hope I'm communicating. So it is electric what? So this is the last formula for calculating what? Electric field what? Intensity. Are we into that? So the SI unit for this one is volt per meter. And the second SI unit is Newton per what? Newton per coulombs. Hope you are we are together. So these are the things I want to actually say here. The third one, it is electric potential. What is electric potential? When we say electric potential, electric